Okay, given that the terminal side of an angle goes through the point negative 2, 3, find all 6 trig functions on that particular angle. So we got to go left 2, up 3, left 2, up 3. 9 plus 4 is 13, so we'll call that a radical 13. And then we need all 6 trig values. So we'll need a sine of theta, a cosine of theta, a tangent of theta, and we'll need the reciprocals, cosecant theta, secant theta, and cotangent theta. Okay, the sine is the opposite over the hypotenuse. That's 3 over rad 13. Cosine would be negative 2 over rad 13 for adjacent over hypotenuse. The tangent would be opposite over adjacent. That's negative 3 halves. And then over here are the reciprocals. So that would be there, that would be there, and this one's rad 13 over 3. So that's all 6 trig values of that particular angle. Okay, graph a function here. So this one is negative 3 sine 2 times x minus a half a pi. That's our function, f of x. Okay, yeah, it's been a while since I've done these. This will be fun. So I can see already that my period is going to be 2 pi divided by 2, so that's pi. I also see that I got myself a horizontal shift here. So as I start to set up my axis, I have a horizontal shift of to the right pi over 2, so I'll go pi over 2. And then I need a period of pi, so I'll go from pi over 2 to 3 pi over 2 to make sure that I get enough period, right? Then halfway between that and that would be pi, and then in here would be a 3 pi over 4, and then this would be a 5 pi over 4. Okay, next there's no vertical shift, but there is an amplitude of 3, so I'm going to make sure that I go up 3 and down 3. You can see it doesn't really matter how well I draw it, right? I can just put the labels in and call them whatever I want. And then one last thing to note is this is definitely a negative sine curve. So I'm going to start in the middle, and then I'm going to go down, middle, top, middle. And then I'm just going to draw the concave pieces that make my general sine curve. So that would be enough for one cycle of the sine graph, right? It continues and continues. A little bit more trig here. Let's solve the equation. There's a cosine, but there's a sine. So let's do as our first step, we'll change this into 1 minus cosine squared of x plus 3 cosine of x minus 3 equals 0, right? We definitely want to get that cosine squared in there, so that way everything's in terms of cosine. 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. And then I'm going to move everything over to this side, so I make that lead positive. So I'm going to go 2 cosine squared of x. That's been moved over there. 3 cosine x over there is going to be minus 3 cosine of x. And then 2 minus 3 is, of course, negative 1, but when I move over there, it'll be plus 1 equals to 0. So does that factor nicely for me? Let's see. Cosine x, 2 cosine x, minus 1, minus 1. Yes, it does. It looks like cosine of x can be either 1 or 1/2. And so the solutions to this for x would be, well, let's see, where does cosine of x equal 1? That happens at 0. Where does cosine of x equal 1/2? That happens at a third of a pi. And it also happens in quadrant 4, which would be 5 pi over 3. And of course, all of these answers have plus 2 pi k for k being an integer. So there's infinitely many solutions. And our last problem is to find the 3 sides of a triangle in which the sides are 6, 8, and 11. 6, 8, and 11. And this, of course, would be a law of cosines problem. Law of cosines. So in interest of time here, I'm just going to go and do, since I've written myself a program that'll do this, I have a program I call try, and I can run this to do my side triangle. I demand the big side first, so I'll go 11, 8, 6. and therefore the 11 is opposite 102.6 degrees. The 8 is opposite from 45.2 degrees, and the other side is opposite from 32.2 degrees. And so those are the answers to this page.